Hey Opties! Today we're looking at some properties of quadratics, and it's really just some applications of quadratics that we discussed in our functions unit, but we're just reviewing those specific things for quadratics. The first is average rate of change, or as I like to say, AROC, just for abbreviation. So here we have the formula. It's f of b minus f of a divided by b minus a. And f of b and f of a, that's function notation to show that's the y value for the x value of b and the y value for the x value of a. So these are x values. The denominator is going to be your x value, so that's the change in x since you're subtracting them. And the numerator should change in y. And this should look familiar to you. This is the notation for slope, and that's what average rate of change is. Rate of change means slope, and it's the slope between 2 points, and we call it average because we use this for functions that do not have a constant rate of change, just to show an average or to estimate things. So let's find an average rate of change over this given interval. So remember that if you have an interval, that's xx, not xy. So sometimes an interval is yy, if you're thinking about an interval for, say, range. But for average rate of change, we are looking at xx. So that 3 and that 7 are x values. So if we look at the x value of 3 and find the y value there using our function evaluation graphical method, we see that this point is 3. And let's count 1, 2, 3, 4, 5, 6, 7, 8. So -8, we went down 8. And 3, and then we count over and we get 4, 5, 6, 7. So this is the x value of 7. And so that's 7 zeros since we haven't gone up or down any. So let's find the slope between these 2 points. And I'll draw that line just so we can visualize. It's the slope of that line. So if we go up 8 to get to our 0, and we go over 4 from 3 to 7, that's going to be 8 divided by 4, which is 2. So our slope is 2. So that's the average rate of change between 3 and 7. Let's look at transformations. So vertex form, we've talked about that in our first set of notes for this unit. And we know vertex form tells us the vertex very easily. And this is a really good display of transformations. And we talked a little bit about transformations in our vertex form video as well. But this is just some notes on how to look for the transformations, just so you can remember. This number out front, there's 3 things that could happen. Could be an x-axis reflection if a is negative. It could be a vertical shrink or compression if a is between 0 and 1, and it could be a vertical stretch if a is greater than 1. This negative h, now this is slightly tricky if you're thinking about what just the letter h does. So negative h, if h is positive, that means you're going to have minus a number, which means you're going to go to the right. So h is positive means you're going to shift right, but that's going to be a negative on the inside because of the subtraction. So it's swapped. It's like swapped twice. It's kind of crazy. You probably won't ever have to really use this type of thinking. You'll probably just look at the equation and see, okay, well, is it subtraction or addition inside with the x? And then you'll know if it's left or right. But if h is negative, then this negative makes it positive, and that'll be x plus something, which will be to the left. Let's look at this k, which is going to affect our y's. Remember, k is the y value of our vertex. That's going to be a shift up if k is positive and a shift down if k is negative. Next, we have domain and range. So remember, domain is as far as your x's can go. For a quadratic or a parabola, remember quadratic is the function family, parabola is the shape of the function on a graph. You're always going to have the domain of all real numbers. So there's 3 different ways you can write this. You can just write it in the words, all real numbers. Or you can write this fancy R. And if you're writing that, I just kind of do 2 sticks before I finish my R. And For interval notation, reminder this is interval notation. Remember, an interval is just XX or YY. It's not XY. It's not a coordinate. That's going to be negative infinity to positive infinity. So here we have our arrows circled, and the left arrow means forever left, which is going to be like your negative infinity in your interval notation. And this arrow to the right is forever right, and that's going to be your positive infinity. So that's what the negative infinity and positive infinity, that's what they go to, those two arrows. So forever left and forever right. Let's look at range. Remember, range is how far your y's can go. So if you have a maximum, then you're going to have a maximum point. So there's going to be a lot of little y values, and then you're going to eventually hit that top y value. So it's going to have to be y is less than or equal to that k value, that y coordinate of your vertex. So it's going to be going to negative infinity. So both of these go to negative infinity. And then you go up to that k. So that's what your negative infinity to k is. And remember, this is a yy, where this was an xx. And the reason it changed is because domain is for x and range is for y's. If you have a minimum, it's going to be the other way around. You're going to be getting bigger and bigger y's, so you're going to have y is greater than or equal to that k value, again, which is the y coordinate of your vertex. And so you're going to start at that k, and then you're going to keep getting bigger, so your k to infinity. So let's do a little practice here. We want to identify the transformations, domain, and range of this given equation. So let's do the transformations first. So this negative means we have an x-axis reflection. And I'll just abbreviate. The 4 is a vertical stretch. We know it's a stretch because it's greater than 1, and that's by 4. Or you could write by a factor of 4, that'd be good too. This plus 3, now your h would be negative 3. So it's going to be to the left 3. And you could look at that chart to know that, or you can just think, okay, well, if it's a plus something on the inside with the x, that's going to be the opposite direction of what the sign is, so it's going to be left. So left 3. And this negative 10 is down 10. Okay, so let's do our domain. Remember, domain is always the same. It's always all real numbers. And I just chose to write it that way. I think that's maybe a little easier than writing the words or the interval notation. And let's find our range. Okay, so it's going to be a maximum because it's pointing downward, or a down end behavior, because of that negative out front, which told us our x-axis reflection. So it's going to be a tip-top point. And that tip-top point is that negative 10. That's a k value. So y is negative 10. That's our k. If you want to write equals k, that's okay too. So we want to write that as our range. So if we write it in inequality notation, that means y is going to get smaller and smaller because it's going down. So y is less than or equal to negative 10. Or you can write it in your interval notation. So you're going to go from negative infinity, and the highest you can get is negative 10. And remember, you're including that. So one thing actually that we need to change over here, this should be including. So it's going to be a bracket, not a parentheses. I wonder if y'all caught that earlier. So if it's including the number, it's going to be a bracket. So again, these are going to be brackets, not parentheses. All right, that's it for some quadratics properties, notes, and practice a little review for us. See you next time.